So this is the third part of pentose phosphate pathway, and we learned earlier that NADPH and ribose 5-phosphate are the principal product of pentose phosphate pathway. So what do we do with this third stage translocase and transketose reaction? So what happens in this reaction is that if we have a lot of ribose 5-phosphate and xylulose 5-phosphate, then this stage of the pentose phosphate pathway, it converts them to fructose 6-phosphate and glyceraldehyde 3-phosphate, which are the product of glycolysis. So it's sort of like an intermediate between pentose phosphate pathway and glycolysis. So the first reaction is reaction 6, which is catalyzed by the enzyme translocase, and in this reaction one ribose 5-phosphate reacts with another xylulose 5-phosphate to produce one pseudoheptulose 7-phosphate and one glyceraldehyde 3-phosphate. This enzyme is catalyzed by the enzyme transketolase, and what this transketolase does is it takes these 2 carbon from the top of xylulose 5-phosphate and puts it on the top of ribose 5-phosphate. So this comes over here, this changes into OH, and we have this CH2OH and O here. Now in my video, if I haven't written anything on the side of any molecule, you should understand that that means there's a hydrogen over there. So this is the first reaction, and this left out part, it changes into glyceraldehyde 3-phosphate. So that's our reaction 6. In reaction 7, so let's talk about reaction 7. The reaction 7 happens between the pseudoheptulose 7-phosphate and glyceraldehyde 3-phosphate, which are basically the product of reaction number 6. And in reaction 7, these two give erythrose 4-phosphate and fructose 6-phosphate, and this reaction is catalyzed by the enzyme transaldolase. You guys saw the enzyme transaldolase in glycolysis if you guys study that. So what aldolase does in glycolysis is, for fructose 1,6-biphosphate, it cuts the molecule in such a way that the position of cut is 1 carbon after the carbonyl carbon. So this is what it cuts, and similarly in this case, this transaldolase, it cuts this pseudoheptulose 7-phosphate 1 carbon after this carbonyl carbon, takes it and puts it on the top of glyceraldehyde 3-phosphate, and when it puts it on the top, this CHO changes into an OH and it makes a fructose 6-phosphate, and this remaining molecule makes erythrose 4-phosphate. So that's reaction 7. And in reaction 8, what happens is the erythrose 4-phosphate reacts with xylulose 5-phosphate catalyzed by enzyme transketolase, and that makes fructose 6-phosphate and glyceraldehyde 3-phosphate. So transketolase, like in enzyme number 6, it cuts off the top portion of xylulose 5-phosphate. The same thing happens in reaction number 6. So in this case too, this top portion it's cut off and it goes and stays on the top of erythrose 4-phosphate. This CHO changes into CH2CHOH here, and this one goes and sits on the top. That makes a fructose 6-phosphate, and this remaining part makes a glyceraldehyde 3-phosphate. So the net effect of stage number 3 is that 2 xylulose 5-phosphate and 1 ribose 5-phosphate, they combine to make 2 fructose 6-phosphate and 1 glyceraldehyde 3-phosphate. So this is the stage 3 of transaldolase and transketolase reaction. Hope you guys understood my video. If you guys have any question, please post it below. Thank you for watching my video. Bye.